Yes, welcome to Gate 22 Biomedical Paper Solutions. So this is problem number 41. Once again, I have already given the answer for the problem number 41 by formal way. We can also try by informal way. Okay, you may feel this route is little easier comparing to the last route, but we can't take a call for the second route. Sometimes the second route may not work, so we should depend on the first route only. Okay, but still you can refer with respect to this problem and see how quickly we can complete this problem by this route. Okay, yes. So given relatively, okay, a big circuit comparing to other problems in your paper. So we have a filter designed by using op amps already given. So it is a band pass. So we need to maintain V naught by VA modulus is equal to 1 since it is a all pass. So to make the entire circuit behaving as an all pass filter, what should be the value of R2? That's a question. Okay, then how answering options are given for R2 in kilo ohms. Okay, so now we'll see how to approach the problem. So let me have a copy of this as well. Then how to answer this problem very easily without really getting into the overall circuit analysis. I'm playing in the outer view. That means this is my V naught by V in modulus, and this is my omega. So at omega equal to 0, it is 1. For any frequency, it should be 1, including omega equal to infinity, it is 1. So that means one can help okay himself by setting omega equal to 0 in the circuit. But remember that we have a frequency selective element that is the capacitor. So this capacitor, okay, let me take it as C, and its impedance or reactance is equal to XC, that is equal to 1 by omega C as per the AC fundamentals. Now what will happen? So if we go for omega and XC as a table, omega equal to 0, XC is going to be infinity, and omega equal to infinity, XC is going to be 0. That means you can set the problem very nicely at either omega equal to 0 or omega equal to infinity. Omega equal to 0, the capacitor is acting as an open circuit. If the capacitor is acting as an open circuit at omega equal to 0, so this is the equivalent. Now we'll see how the analysis is going to be very instantly going to give the answer. What is your expectation? This is your VN. And what is you're expecting here? It's also VN. Okay, so that's a DC signal because omega equal to 0. So we are exciting the entire filter by a DC signal. So, and given it's all pass, whatever the input I'm giving, it should be there in the output. Okay, I'm expecting the output to be V in, but unfortunately this capacitor is acting as an open circuit, so it is completely open means, okay, so this is a V naught, you know already, you calculated this as minus V naught. So there is a minus V naught contribution, there is a V in contribution, no contribution will make an output here. But here it is going to create a trouble. This op amp is out of negative feedback. That means you may have a feel of it is going to saturate negatively or positively to plus 10 or minus 10, depending on its VD, For some reason, let me take it is 0. Okay, for some reason, okay, let me take 0. That means there is no contribution coming from this op amp because the capacitor is acting as an open circuit. And finally, I need to prove that this is going to be 0. Okay, so this is not making any contribution, means this 5K is not coming into play because this is at virtual ground, because it is maintaining VD equal to 0. So that means there is no contribution from this side because it's a 0 milliamps current. So left hand side is 0, right hand side also 0. Then who has to contribute your output means this is a feedback path. So then nothing is coming from this side and everything should come only from this side. Everything should come only from this side. So that means play for this side. This potential is V in. Okay, then this gain is equal to what? Minus 1 because of identical resistors. So this is going to be minus V in. Therefore, minus V in is coming at the input of R2 and 5K is not playing the role and only the 10K is coming into play. That means straight away I can say I know the V naught. So I can say now V naught is equal to what? Minus 10 kilo ohm divided by R2 into what? Minus Vn should be an output that should be equal to V. If that is the case, Vn will get cancelled. So then what is the only possible result? V naught should be equal to Vn means, so 10 kilo ohm divided by R2, okay, into Vn should be equal to Vn means, so 10 kilo ohm by R2 must be equal to 1. No other choice. R2 must be equal to 10 kilo ohm. ohms. Yes, like that we can complete the problem very instantly by playing at omega equal to 0 itself. But we assume this potential is equal to 0. We have to prove it. Okay, if you prove it, yes, the problem is over. So we need to prove this potential is 0. So there is no contribution coming from this side because there is a good chance of op-amp getting into saturation, and see how the circuit is helping itself, okay, to avoid that saturation. Okay, so this point is V in. So let me take this also equal to what? V in, because V not equal to V in. And this is another inverting configuration with a gain of what? -1. If that is the case, this potential is equal to minus V in. See this, that's the beauty of this problem. And here you have plus V in, and here you have minus V in, and it is an open circuit, and therefore the current is going to exist only in this path, and then it's V in and minus V in means, and this point will be differently at ground potential. That means there is no feedback, there is no virtual short in this, but the inverting terminal is at ground, non-inverting also already at ground. So VD is equal to 0, irrespective of ideal op-amp gain, still the output of this op-amp will be 0. Therefore, you are perfectly all right with the concept. So then at omega equal to 0, expecting the gain is equal to 1, this is how the circuit balances and how it is making it as a all pass function. Okay, so simple. It is mentioned as all pass. So at omega equal to 0, modulus of V naught by V in must be equal to 1. We are helping ourselves by setting V naught is equal to V in at this frequency where the capacitor is acting as a open circuit. That's a very interesting way. So you need not to force yourself to play only for omega equal to 0. You can also help yourself by playing at omega equal to infinity. That's another way. But still, what is that? This is V in, and again expecting the output to be equal to V in. You can also try this way because you may feel the first op-amp, this op-amp may be driven to saturation because of the open circuit. If that is the case, you go for omega equal to infinity, then Xc is equal to 1 by omega C is going to become 0 ohm. That means this is going to act as a short. This is also another interesting play, but this is a little time consuming. Okay, so this is virtual ground, and since it is a virtual ground and there is no impedance offered by capacitor, again this point is going to be 0. That means irrespective of what is here and what is here, this contribution becomes 0, and this cannot contribute this way. So once again the problem takes the same shape of the previous route. Okay, so there is omega equal to 0 condition. Now at this point, what is your input? It is V in. Again its gain is -1, so it is going to be minus V in. Then no contribution coming from this because this point is still 0. This current is 0. So once again your output V naught is going to take what? Minus V in into the gain. What is the gain? Minus 10 kilo ohm divided by R2. That should be equal to V in. Yes, the equation is same. Expected this may take little more time, but okay, both are equally good. Omega equal to 0, you can set the problem, or you can set the problem at omega equal to infinity also, and both will conclude V in into 10k divided by R2 equal to V in. Both will conclude R2 is equal to 10 kilo ohm. So the answer is 10 is your answer. Perfect answer. I have given a fundamental route that is relatively more time consuming. So if you already practice this kind of problems, yes, already this kind of problems happened in the biomedical paper, expecting how we can play quickly, that's a way. Okay, so set the problem at omega equal to 0 or set the problem at omega equal to infinity. Both will give identical equations. Okay, because the gain is equal to 1. Play with that, exploit it. Okay, then. So play for omega equal to 0, play for omega equal to infinity. Any other frequency not required. It will complicate things. Okay, either the capacitor acting as an open or acting as a short will help you to complete the problem instantly, even though the circuit looks complex. Okay, that's a very interesting way. So we'll update you with the next problem soon, and hope you enjoyed this content. So do subscribe our channel and also share to your friends.